Hello everybody, welcome to episode number 16 of the BIVBlog, Benedict's IT video blog. My name is still Benedict Stockelbrand, and today I want to show you what progress I've made with the network-based installer that I'm currently building. But first things first, because this is episode number 16, this is an anniversary sort of thing, because it's now a 2-digit episode even in hex. Haha. Great. And I think give another couple hundred episodes, I'll probably get the hang of this as well. Anyways, if you've watched the previous episode, there were some hints that I've been actually working on this installer thing using my rescue system. And actually, when I recorded the last episode, things were actually already working, but I wanted to spare you all these trial and error sort of things that I've been going through to get this all up and running. So last time we focused on building a rescue system. This time I'm going to show you how to use and extend this rescue system to install binary disk images onto a target system. And once everything is put together, it's fairly straightforward, but getting there, well, it was fun. Okay, so next thing I want to do is create a bunch of images, and I expect some sort of fun there. I've already been working on that a bit, but we'll leave that either to the end of this episode or to another separate one. What I want to show you today is just how the installer works. So let's take a look. Now, what does the installer do? Let's try. Again, I use a Xen virtual machine for this. And as you see, I've got bootable systems, one called installer, which we've set up last time, which I've extended, and Wheezy is the rescue system that we've built a couple of episodes ago. So the system boots, and as usual it takes a moment, especially because it is running in a virtual machine, so it's waiting for 25 seconds. But once it has booted, it actually provides me pretty much all I need to install my training machines very quickly, very conveniently, and most importantly, let the course participants do this themselves, so I don't have to deal with this in front of the class. So here you see how var is being populated. We've seen that in the previous episode, how I did it. And once that has happened, the system should be pretty much up and running in just a couple seconds or so. Come on, get going. This is annoying, but there's nothing I can do about it, really. It takes a little time. There we go. And here's what's new. So basically, what can I do at this point? I can reboot the machine. I'm not going to try that at this point, because then we'd have to wait for it to come up again. I can erase a disk, and erase means just fill it with def0. And why did I do this? Because if you take computers across certain borders into certain countries, you might have your computer searched, and if you have some business related stuff on there, you might decide, no, not with me. So if I want to go there, or if I have to go there, I want to erase those disks. And then I have a couple images here that I've already prepared. I'll talk a bit more about that later on, but for starters, the image I want to show you is something that you can get from the FreeBSD FTP server, which is just an image you'd normally copy on a USB pen drive. And I'm going to install this because you can install it on a hard disk as well. So I'd select it, then I'd select the disk to use. And yes, even if there's only a single disk, this program is not clever enough to decide, okay, there's only one disk, let's use this one. Mostly because this is the last chance to decide, okay, I think I made a mistake. But anyway, let's install this. And here you see what's actually being done. It's decompressing the image because it's compressed, and it's DD'd out to the target disk. And here you see one of the reasons why I use images. It's 700 megabyte size image once decompressed, and it installs in less than 10 seconds. You can't possibly beat that with an installer that tries to unpack tarballs or whatever package files. No way to beat that. And even if it's only running at 77 megabytes per second, if I was doing this on a physical machine, speed might actually be even slightly better. But then 10 seconds, there's not that much to gain if I was tuning this. So we're back to the same menu once again, and at this point I actually say reboot. The system does reboot, and oops, there's the window, the screen viewer gun. Anyway, it boots from hard disk this time, and it boots FreeBSD. And that's pretty much all there is to it. So you see, it works reasonably well, reasonably simple. And one question you might ask at this point is, why do I use images rather than package systems? First reason, as I said, is this is tremendously fast if you do it right. You can't beat DDing an image straight onto a disk. You get the full sequential write speed of the disk. You can't get that anywhere else. And the other one is that no matter what sort of image and what sort of file system I use, I can install it from FreeBSD, from Debian in this case, because it just copies a disk image somewhere. So I've got FreeBSD, NetBSD, OpenBSD there. I could put macOS there if I had Macs for training machines, which I don't. I could have what? Current or Windows. Woohoo. We'll see more about that in a while. And it just works no matter what. So those are the reasons why I use images. And yes, it is enormously fast. Even with a Windows system, which I've already tried today, which has a size of about 30 gigabytes, installing onto a physical machine takes about 6 minutes, as opposed to 2 hours it took me to install the machine so I could take the image. It's like 40 minutes or so to install things. And these Toshiba things with the rescue CD, they shut down, they turn them on, they say, okay, now preparing for first use. And then it's another 45 minutes or something like that, installing drivers and doing things and rebooting, I think 57 times. And you can't turn off the sound really, so you have got all these funny, corny sounds. Yeah, I'm starting up and I'm going down, and I'm starting up again, I'm going down. Drives you crazy. And I've only done that with one machine. If I do this with all 13, it's just one of those days you want to take a couple hours off. And then you come back and realize, okay, stupid installer asks some stupid question again, and you say, okay, do it, then continue to make noise. So this is really something, installing a machine within 5, 6, even if it was 10 minutes, that's tremendously helpful for my line of work as far as trainings are concerned. In a data center environment, I wouldn't be quite happy with this sort of setup because it's missing a couple features and it's doing a couple things in a way that is not really the best in a data center environment. But the problem here is, with all these installation frameworks you get, starting from Jumpstart for Solaris a long time ago, to Phi, fully automated install from Thomas Lange here in Germany, for mostly Debian, or Kickstart for Red Hat, Fedora stuff, and whatever else. The problem is different people have so many different requirements that if you try to cater for them all, those things get tremendously big and complicated and hard to use. So I rather go for a little thing like this, and you'll see how simple it is, tailored to my particular needs. And if I decide, okay, I want to use the training notebooks while I'm not doing trainings to play around with a high performance cluster or grid, or latest buzzword I've heard is private cloud, pretty much all the same really, then I can just change this to do things less interactively. Basically I boot the machine, tell it boot across the network, and it installs the one image it's supposed to install hands-free, and I don't have to worry about it. But if I wanted that, if I needed that, I'd have most of the things in place. I just have to change a couple things, so I didn't use this dialog to select an image, but do it, for example, based on a per machine decision. So that's what I've got, and that's pretty precisely what I want. And next question, of course, is how does it work? And I think you might want to know as well. So let's take a look at this too. Okay, here you see the, by the way, the memstick image, and it's suggesting to install FreeBSD as well. But we don't need that any longer. So let's instead take a look at the script that was running on the rescue system. And here it is. It's actually fairly simple. I tell it in the beginning where to find the installation images. No big deal really. And this is the mount point. The thing is mounted through the etcfs tab already, which we've seen in the previous episode. There are two programs to create these simple text-based dialogues. The old one is called Dialog, and on Debian it's not called Dialog any longer, but there's a successor called Whiptail. So I use an environment variable to make it work on either one. But no, I haven't tried this on FreeBSD just yet. I do a couple things. I change into the image directory because it simplifies the rest of the code, and then I try to find all potential images. And you see I support uncompressed images, gzip, bzip2, xz, and LZO compressed images. And the reason why I do an ls is so they are sorted by name, and why I pipe the output, the standard error output to, or redirected to def null, is because if there are, for example, no bzip2 files, I'd get an error message, which might be a bit irritating if you see this. And then if there is a file like this, remember that if there is no matching file, you might actually get these parameters. Then I check if there is a file name .restrict. If it exists, I execute it in a shell, and if it returns true, I accept the image, otherwise I ignore it. And if no restrict file exists, then I'll offer the image anyway. Why do I do that? Because these restrict files allow me to control which images can be installed where. For example, I can check, is there enough disk space? Does the machine have enough memory? Does it support virtualization? Is it of a certain hardware type, like these notebooks, so I can ensure I install an image with the necessary drivers. Possibly I might even check for serial numbers or such to install particular images to particular machines only. Using a script like this gives me all sorts of options to do this. Then I add some things to a string called image args, which I then use in an invocation to Dialog or Whiptail to select one of the images. And I also offer to reboot or to erase whatever disk. If I select reboot, I reboot the machine right away. The reason why I put the sleep 10,000 here is because reboot immediately returns, but that means you get the following code, which shouldn't really come up because the machine is supposed to reboot. Anyway, if I don't select reboot, I look for all disks and then offer a similar menu to select the disk to use. If I cancel the operation in either case, then I just restart the program using an XX0 here and here. And otherwise, I check what sort of image it is, in what format, or erase the disk, or set up, or in any case set up a variable command, which is what I execute later on. And then, well, what do? I say what I'm going to do, always helpful. Then I run this command. If it returns success, I output operation completed. Otherwise, I say operation failed. Now, when I erase a disk, I eventually run into an error that says disk is full, end of disk or whatever. So it's reasonable to put a little comment in there to avoid greater confusion. Of course, it would be nicer if this error was actually checked for and I could be sure from within the script that the entire disk was wiped, but that's not quite trivial. I could figure out the size of the disk and then give DD a count option and whatever, but I decided it's not really worth it. The key exercise, or the key point in this exercise, is to keep things as simple as possible. Okay, once we're through, I wait for return to be pressed, which I just read into a variable junk, which doesn't do anything, and then the whole thing ends, which actually means it starts over again, because how is it started? That's the other trick. I fact up the init tab on the rescue system. And as you see here, this is what the line originally looked like, basically meant on TTY1 start a Getty, and I modified that to make the Getty automatically log in as root and then start a login shell, which is not a login shell but the script I've written. And that's all there is about it. So, not a big deal. Another thing I had to do in the makefile was, as we've seen before, in the FS tab I added a line to mount the NFS share with the images. So that's pretty much all there is to it. And once you got that sorted out, it's actually rather simple. Anyway, why did I do it like this? Okay, it's probably obvious that I've been using images for the reasons I've mentioned, but why did I just install images and not go whole hog like, you know, Jumpstart and Fire and such, install packages, configure things and so on? Simple reason. For the training environment, it just doesn't make sense, because people will set up their things according to their own needs. And even for a sort of a data center environment, which I pretty much always have in the back of my mind, it's not really sensible to use a full-blown automatic installation configuration framework at this point. There are situations where this is useful. Most specifically, if your normal mode of operation is that you install a machine and then run it, and if you want to change things, you install it over again. I've seen a couple environments where we used to work like this, and in those cases tools like Jumpstart and such do make sense. But if you want to manage a running system, what you normally use is tools like Puppet or CF Engine or Ansible, Chef, whatever. There are quite a few of those. And if you use these anyway, in my case I use Puppet. If you use them anyway, it just doesn't make sense to put the configuration into the installation system and then in the configuration management system again. It's just double work, you'll get inconsistencies, and it makes things unnecessarily complex, and you'll have to keep those consistent. So my goal at this point is I install an image on the training machines to the point that people say, okay, from here on I can do whatever I want. And on a data center or whatever sort of environment, all I want to do is be able to configure the machine using Puppet, in my case. So everything else should be left out. It just makes things more complicated, and you wind up with a tool that's tremendously powerful and complex, and the only thing you get from it is spending a lot of time reading documentation about things that you aren't interested in, and deciding, okay, I don't need this, I don't need this, I don't need this, I don't need this, and eventually finding what you do need. So that's not really what I want. Couple things about security. I've already showed you I can blank disks. Can be quite useful in certain situations if you don't know who might get physical access to these disks and what has been on them before. And another one is that you can't protect the target machines that are being installed from being manipulated by a rogue install server. Nothing you can do about that, except keeping rogue install servers out of your network, what you have to do. You can, however, protect the server by exporting things read-only and so on. And I've done that. So even if I have people in a training course who'd like to see if I figure out what they've just done, and occasionally you have these sorts of people, they can't cause that much trouble, at least not to me. So that's reasonably helpful. Finally, this restrict mechanism, so I can install certain images on certain machines only, can also be used as some sort of security mechanism. So you can say, okay, this machine gets these images, this machine only gets those images. And yeah, that might be helpful as well. And another question is, why do I use uncompressed images and various compression types for these images? That really depends on what you're going to do. Now, if you set up an image and want to test it, having to compress it first, you can put it in there, it takes a tremendous amount of time. Depending on the compression algorithm you use, it can be, for the Windows system I've tried, it would have been probably something like 2 hours to compress it. So I want to use uncompressed images for testing. And the different compression formats that I've used, they are rather different. LZO is the worst compression as far as compression ratio is concerned, but it's tremendously fast. So it puts fairly little load on the target machines. It compresses rather quickly. So if I want to take an image and I don't want to wait 2 hours for things to happen, but rather 10 minutes, then I go for LZO. gzip is compressing significantly better, takes more time to compress, significantly more time, but it decompresses faster than the I/O bandwidth of the hard disks in these notebooks. Of course, depending on your hardware, your mileage may vary. bzip 2 is just slow, and XE is slow but compresses impressively well. So XE might be interesting if I have large numbers of machines to compress simultaneously. So the bottleneck would be the bandwidth from the server or the disk storage on the server or the network from the server to the clients. And the clients would be waiting for the data to come anyway. That said, on these machines, XZ decompresses at about 35 megabytes per second, and the hard disks do about 100 and 110. So XZ is really only useful if I have to install at least 4 or 5 machines at the same time. Anyway, you've seen in the script there isn't that much to adding another compression format, so I just put them in there and be done with it. And well, that's why I've done it like this. Now, if you build something like this for yourself and for your particular purposes, again, how Dave Jones say, there is more than one way to skin the cat. You have 2 options. You can use something off the shelf, possibly even something commercial, and it'll be overwhelming with features, most of which you don't need, but other people do. Or you can just, write a 100-line shell script and get what you need. What you want to keep in mind in any case is performance. And there are a couple things about performance that are relevant. There's the disk space on your server. If you have a sufficiently large number of images, these actually take up space. And they have to be transmitted from the disk to the server and from the server into the network. So network performance on the server side can be an issue. Network performance on the client side can be an issue. If you have a decent server network interface in the server, but some cheap-ass network card in your target machine, that can actually be a bottleneck. And yes, there are significant performance differences between network cards in some cases. You can have problems with the disk I/O on the client side. For example, these notebooks here, they have 2.5-inch hard disks. If I have a pile of SSDs in a RAID 0 configuration or whatever on the server side, then the disk I/O on the client may be a bottleneck. And when it comes to decompressing, the CPU on the client side can actually be a problem as well, because it might be the slowest part in the entire chain if you use an ill-chosen compression algorithm. So that's pretty much the potential bottlenecks. And when it comes to workflow, one thing is creating images, or the turnaround time to create an image. In that case, the easiest thing is normally just don't compress at all. If you have to compress for some reason, your best bet is probably LZO. And once you get this sorted out and keep this in mind, you should get to a point where you can install a machine within a few minutes. And if you have a couple dozen or a couple hundred machines, it's still tremendously fast, and it's way more convenient than running around with Windows recovery CDs or such. Well, so much about that. Next question is, what about creating these images? There are quite a few potential pitfalls there, and a number of tricks to, again, speed things up, to optimize things. But I guess I'll leave that for the next episode, and hopefully gonna record that tomorrow. Anyway, I hope this was kind of interesting. If you have questions, suggestions, want to do things completely different for your purposes, come over to the forum at www.stapler-it.com/bivblog/16. If you would like to have the makefile and other stuff, I'll put the tarball there as well, so you can use it. Feel free to use it for whatever legal purposes. And yes, it's gonna be BSD copyright, so yes, you can use it for commercial purposes. Just leave my name in there and don't sue me if it doesn't work. That's BSD copyright. And if you watched this on YouTube and liked it, do me a favor and give it a thumbs up. And in any case, hopefully See you again next time. Bye.